on the technology methods for two sample means, two means that are independent of each other, like we talked about yesterday. And this is where we're going to use technology to do our hypothesis testing and also our confidence intervals. So I have one problem here to go through, each one on StatCrunch and also on the calculator. And tomorrow we'll kind of choose which one we like best and go with it like we've been doing. So let's read this one. Researchers from the University of British Columbia conducted trials to investigate the effects of color on creativity. Subjects with a red background were asked to think of creative uses for a brick. Gonna be real creative. Other subjects with a blue background were given the same task. Responses were scored by a panel of judges, and results from the scores are below. The researchers claimed that the blue enhances performance on a creative task. Test the claim using a 0.1 significance level. And here's our stats from the red background. Means a little bit higher, a little bit better scores. Sorry about that, a little bit lower. The blue background is a little bit higher, one more person in the sample. Standard deviation is a little bit less, but the mean is higher. So they're saying, okay, blue helps with creativity. So we're gonna do two things. Test with the hypothesis test first, and then we're gonna test the claim with the confidence interval. Start with your ho and your ha. Our ho, just like last week, and just like we talked about yesterday, is going to be the first mu and the second mu are always equal to each other. We're going to assume they're equal, that the background color does not matter. And I put the mu1 is less than mu2 because they said the blue increased it, and the blue was the second one. It was the second mean up here. So that means my first mean has to be less than the second mean. Is their claim. And we're about to find out if that claim is true or not. Let's go to calculator first. I'm gonna pull that up here. Here's how we go. We're gonna go to stat test, and remember we're doing means, which is a two sample t-test. So what I'm looking for, two sample t-test, which I just passed, is number 4. T-distribution, because we're doing means, so hit number 4. And I've already punched the numbers in there for us. Now, one thing that's different today is it's going to ask you one more question here on the bottom. I chose less than. It's going to ask you whether you want it pooled, and you're going to say no today because that's only if they're matched pairs, and we're not matching the pairs. So I'm going to go on down here, calculate. I do want to calculate, so I'm going to hit enter. And there's my t-stat, and there's my p. P is very low; it's below 0.01. So we're gonna reject HO. And we would say, there's our HO. You can still see it down on the bottom of the screen. We're rejecting our null hypothesis, so there is sufficient evidence to support their claim that the blue helps creativity. The other way we're going to go is a confidence interval. So I'm going to go back to stat, go to test, and I'm going to scroll down. I'm looking for a two sample t interval, which is, I think it's a 0. Yes, it's right there, it's 0. So hit 0. Comes up. I've already typed them in again. I chose 90.98 because if you can still see the problem. The problem had a 0.01, and because it's a one-tail test, it's really should be 0.01 right there, not 0.1. But I doubled the 1% to 2%, which gave me a confidence level of 98%. It's not pooled, so I'm going to calculate right there, and right on top of the screen, hopefully, right there it is my confidence interval. Now, like we did earlier and last week and yesterday, because 0 is not included in there, that means there is a difference between my two mu's, and which means we're going to reject the fact that they're equal because the difference is not 0. So there is sufficient evidence to support the claim, even if you use confidence intervals, and that's how we do it on the calculator. Let me show you StatCrunch next. See which one you like better. There's my StatCrunch. I don't think I can do this without splitting the screen. Nope. Let's split the screen real quick. Sorry about this. Okay. To use StatCrunch, I'm going to go to stat. We're doing t-stats, two samples with summary. All right, sample mean. And my first one was 3.39. Sample standard deviation of the first one was 0.97. Sample size of the first one is 35. Same thing for the blue background. The sample mean is 3.97. Sample standard deviation was 0.63, and the sample size was 36. And I'm gonna come down here, check what I have here. It's pooled variances. I'm not doing pooled yet. I want that to equal 0. I need this to be less than right here, Don't worry about the numbers. That's for confidence interval only. The hypothesis test, just those two things. Hit compute. And if you notice, that's the exact same t-stat and the same p-value I got a minute ago in the calculator. Exact same way to do it. All right, let's go to options. We'll go to confidence interval now. Go to options and edit. And all I'm going to do is I'm going to take off the hypothesis test and go to confidence interval. Just got to change my level to 0.98. That's the only change you have to make. All the numbers are still the same. Hit compute. And there's my lower limit and upper limit. That is my confidence interval right there. And again, because 0 is not in there, I can reject my HO because it says they're equal, which means there is no difference. There's always a difference because I did not get 0 in my interval. So I can support the claim. And there you go. It's so similar. And I hope you start seeing the patterns here as we go different sections recently and how technology is helping us so much. So really all I got. Hope it helped. We'll work with the technology tomorrow and do some problems in class, maybe mainly a work day again, and I'll see you then.